introduce Dan Jeline from the UNC Highway Safety Research Center.
Okay, thanks so much, Matt. I'm grateful that you all are continuing with us today. Hopefully you attended our part 1 episode of this series on Tuesday. If not, we have some resources to kind of get you a recap on that episode. Today we're continuing with part 2, the final episode of this particular series. We have some of the same panelists back and a few others joining us today. We're going to shift gears a bit and think about how individuals who are blind and have low vision navigate our streets and line up at their crossings, talking a lot about tactile warning surface indicators and really just getting a sense of how we can improve our intersections and our street design to make sure that they are accessible to all road users and all pedestrians. So I'm glad that you're here to join us for this session. I wanted to first introduce you to the panelists who are joining us today. So let me do that right now. Joining us again is Janet Barlow, who is an orientation and mobility specialist with Accessible Design for the Blind. Janet has extensive experience teaching travel and street crossing skills to individuals who are blind or who have low vision. And for the past 20 years, she's worked on research related to accessibility of sidewalks and street crossings to pedestrians with disabilities, focusing mainly on travel by pedestrians who are blind or visually impaired in complex environments, particularly street crossings. We're also joined by Donna Smith, who is the manager of accessible services for Sound Transit. Donna has over 35 years of experience as a professional in the field of disability advocacy, with most of those years as a training and technical assistance specialist on disability-related laws and issues. Since 2002, she's focused specifically on transportation issues, and her areas of knowledge pertinent to accessible transportation include ADA rights and responsibilities, travel training, coalition building, transit experience from the customer's perspective, and the accessible pedestrian environment. Dr. Billy Louise Benson is with us as well. She is an orientation and mobility specialist and director of research at Accessible Design for the Blind. She has taught people who are visually impaired to travel independently for more than 30 years. She's best known for her research on ways to improve environmental access for people who are visually impaired, including such means as large print tactile and electronic signs, audible signs, tactile maps, accessible pedestrian signals, visual contrast, detectable warnings, and various wayfinding technologies. And finally, we're joined by Dr. Robert Wall Emerson, who is a professor in and coordinator of the Department of Blindness and Low Vision Studies at Western Michigan University. He is a certified orientation and mobility specialist, has worked as a teacher of children who are blind, and has been conducting research into aspects of blind travel for over 25 years. He's published more than 75 peer-reviewed articles and 7 book chapters on a wide variety of topics involving navigation of people who are blind and teaching children who are blind. And I'm so excited to have this great panel with us today. One thing I want to mention as we go through our presentations today, we're all going to strive to, for any visuals we have, to really describe those images in some detail so that information is accessible to everyone. I've already posted a PDF copy of the presentations being shared today on our website, and the link to that I'll push out to you in just a moment. We have alt text equipped in that package that is available to you as well for all of the images that we share, and we're providing some subtitle information on the video recording when we post that later. So we hope that this information is getting to you in the way that you need it. We will strive to do that throughout the entire session, respecting that need on everyone's behalf. What I'd like to do first now is turn it over to our first presentation from Janet Barlow to provide a bit of an introduction for us. So Janet, do you want to go ahead and take over the screen?
I've lost the controls somewhere here. There it is.
Dan, well, Janet, get started. Once again, this is Matt from VHB. I apologize. I should have mentioned at the beginning. At the bottom of everybody's attendee screen, you're going to see 2 buttons. There's a Q&A button. You can fire that up and send in questions, and we are going to keep an eye on those throughout the presentation, and later on we'll do our best to address the questions as they come in. And if you're unable to use the Q&A or you prefer to unmute and talk to us, there's a raise hand button you can click to get our attention later on. Thanks. Sorry for the interruption.
That's okay. You gave me time to get sorted out here. I'm going to talk a little bit today about how blind people travel. This is a shortened presentation from what I provided on Tuesday. with a little more information about wayfinding issues. Do go back and look at this slides from Tuesday and the presentation from Tuesday if you missed that, because there's some information on various types of vision loss that would be helpful, I think, to your understanding of the needs of people who have low vision. Just a question that always gets asked, I'm going to reiterate here, is that we don't really know how many people are blind or who have low vision in the US. There's no registry. The 2017 National Health Interview Survey basically came up with 26.9 million American adults age 18 and older who reported vision loss. That doesn't include children, of course, and may be missing a lot of the older adults who are in assisted living or nursing care facilities. Photo on the screen is the photo of an older man with his hand on a push button type device. He has a white cane and looks like he's waiting to cross the street. Person with low vision, and this is specifically important to understand, that is not totally blind. Those limitations in vision, though, can affect the ability to see signals, both the vehicle signal and the pedestrian signal, affect the ability to judge the traffic approach speed and distance, and particularly affect understanding drivers' intentions. There's often the kind of advice to pedestrians to, you know, see if the driver's looking at them, or watch for the driver to be waving them on. And that doesn't work very well for many people with low vision or who are blind. And depending on the vision loss, level of vision loss, person may not be able to easily find the crosswalk location. They may be depending on the markings and the marking type, and may have difficulty with seeing things like curbs and islands or curb ramps. We have a growing population of older population with low vision. And vision really can vary with different kinds of lighting conditions. One of the things that is common with older travelers is reduced contrast sensitivity. They need more contrast to see objects. That may affect their ability to see things in the public right of way, to be able to see things like a pedestrian signal against a white walking symbol, the walking man symbol against the sky. They also may react more slowly and move more slowly. The photo on the screen here shows an older man wearing sunglasses who's approaching a sign projecting from a post at head height. One of the other comments that's part of the presentation I gave the other day that I just want to reiterate here is that many people with low vision do not use a cane or dog guide or any kind of device that makes you think or recognize that there's someone with low vision. For somebody who's blind or low vision, they have several transportation choices. Usually they can't drive themselves, but they can walk or use public transit, bus or rail. Some use paratransit services, taxis, ride services or shuttles, and may get rides from friends or relatives or use paid drivers. People often use aids and techniques for obstacle and curb detection. Photo on the screen is of a man with a white cane extended in front of him while crossing a street. There are choices about what techniques are used by different people. White cane is used as a probe of the walking surface, detects changes in the elevation or obstacles in the path. It also identifies a person as visually impaired or blind. Dog guide is a commonly kind of assumed aid that is used by people who are blind or visually impaired, but is actually used by only a small percentage of individuals who are blind or visually impaired. Photo on the screen of this slide is an individual crossing the street with a dog guide. But dog guides don't solve all the travel problems of individuals who are blind. They do guide around obstacles and stop at curbs and drop-offs, but doesn't make the decision about when to cross the street and kind of what to do when there's an obstacle that's blocking the whole sidewalk. The handler makes the decision and provides a command to the dog. The handler also directs the dog along a route with commands such as right, left, forward, not commands such as take me to the grocery store. And then other aids, some individuals with low vision may use additional aids or aids such as a telescope just for specific tasks like reading a sign. In crossing the street, crossing cues used at signalized intersections are the traffic stopping, vehicles starting and stopping, moving across the intersection, or accessible pedestrian signals. At different cues are used at unsignalized crossings. People need there to be listening for vehicles approaching or no vehicles, or hearing a vehicle yielding, and often listening to traffic moving parallel to the crosswalk that would keep a vehicle from crossing the crosswalk. Those cues aren't available at many types of unsignalized locations and may make those crossings difficult. Orientation and alignment cues, and that's what we're really going to be talking more about, I think, today in this webinar. We talked more about signals and issues with signals in the webinar on Tuesday, so please consider going back to that if you're interested in those or concerned about those issues. But in orientation and alignment cues, people use different things and different techniques work for different people. Individual may use slight slopes and changes in the surface texture, the sidewalk edge or grass line, building line. They use the sound of traffic, both parallel to their travel path and perpendicular to their travel path. And when available, they pay attention to and use other information, such as other pedestrians moving, the sun, various other cues, sound cues that may be common in the environment, or other information that can be gathered tactually and auditorially. For orientation, it's generally helpful to have an awareness of the intersection streets and general layout of an area. There was a project that we looked at that looked particularly at some orientation and alignment cues and wayfinding for individuals who are blind or visually impaired, particularly at roundabouts and channelized turn lanes. It was NCHRP Project 378B, Guidelines for the Application of Crossing Solutions at Roundabouts and Channelized Turn Lanes for Pedestrians with Vision Disabilities. Part of that project was research on wayfinding at roundabouts and channelized turn lanes, and noting problems that participants had. Also found some of the features that improved their ability to find the proper location to begin crossing and to align to cross more accurately. We were not looking at locations where tactile warning surface indicators were installed, and that's going to be more what we talk about in later parts of this presentation. But NCHRP Report 834, which was published in 2017, did include a wayfinding assessment, which can be applied possibly to other types of intersections. So I encourage you to look at that report and the information provided there as additional information regarding wayfinding and orientation and alignment cues. Just a photo that's an example from the guidelines in that publication. Photo is of a roundabout with a fairly wide sidewalk, but a landscape separation between the sidewalk and the street. Grass strip that followed the curvature of the street and ends right at the crosswalk. And so that's a detectable landscape separation at roundabouts that helps individuals who are blind or visually impaired actually find the crosswalk location accurately. And just to reiterate, information that is helpful and everybody needs to remember is that people who are blind do travel independently to new places. They are not oriented to every place they may go. They're going to be traveling to unfamiliar destinations for shopping, errands, visiting friends, children's activities, all the kinds of things that those who are fully sighted might be doing. They're more likely to be using transit and walking and not driving themselves. They may get directions from people or use an GPS device. They walk along the streets and get to intersections and basically have to figure it out when they arrive at them. And if they're unaware of changes to intersections or just not familiar with the intersection, they may at times make dangerous decisions. And that may be true when the layout's unconventional or when some kind of familiar intersection has been changed. So we'll talk more about a lot of these cues that people can use and may use in traveling, and I'll turn it over to Donna, who will talk more about that.
Thank you, Janet. Let me get my screen shared here. All right. Thank you, Dan, for inviting me to participate in this webinar today. I'm happy to be here. I'm going to talk a little bit about the travel experience of people with vision disabilities. I'm sorry, I thought I had unmuted myself. I'm very happy to be here, and I'm going to be talking today about the travel experience of people with vision disabilities from two perspectives. One is my own personal perspective as a person who's blind, who gets out and about and goes places, and then also as a professional that works in the public transit industry, and we give a lot of consideration to how pedestrian facilities interface with our transit facilities.
Hi,
Donna,
sorry to interrupt. We're not seeing your slides yet.
you may need to try the share screen button again.
Is that it? Is it showing now?
Not yet.
After you select the screen you want to share, there's an additional click to actually finalize it. Oh, there we go. Thanks, Donna.
Great.
All right, are we up?
Yes.
Okay, thank you. Sorry about that. All right, so we're moving on to slide 2 here. Do people travel differently? I know you're thinking, wow, did she come up with that all by herself? It is a very simple truth, but it's one that's also frequently ignored. We tend to be rather norm focused in our projects. And so when we start to design and build, we think about who's going to be using this and what are the majority of the people who might be out using this going to do. And the majority of the people are always going to be people with vision, never people without vision. And so what we're hoping to urge you to do in the webinar that happened on Tuesday and the one that's happening today is to give some consideration to something beyond the norm. But the norm is maybe a really easy way to look at things, but it's an incomplete view of who will be using our transportation and our pedestrian facilities. So there are a number of factors that impact or that have an ultimate impact on how people who are blind travel. We're going to run through a few of these. So one is the onset of blindness. So when did blindness occur in that person's life? I was blind at age 3. And so I grew up learning to do everything I do as a person who's blind. So even from my very earliest, getting around my own house and yard, I learned to do those things as a person who's blind. However, if you are, say, 43 and lose your vision, either a significant amount of vision or all of it at that age, then you have quite a learning curve to achieve to go back and relearn skills that will help you to continue to do all the things that you normally do or that you had been doing with vision and now being able to do it without vision. There's a lot of training that is available. So orientation and mobility is the profession that teaches people who are blind or have vision disabilities how to travel independently. The good news is that this training is relatively available around the country. If you are a student who is blind and in school, you can receive these services while you're in school, or if you're an adult who loses vision, you can get it through other rehabilitation programs that'll come out. So that's the good news. The training is available for people to get, and it's a training that is obviously very essential because it lets you get out and about and take care of your world again. And it's also very empowering. There's nothing like that feeling of, okay, I can do this on my own now by myself. That plays a big role. Then there's the opportunity or the willingness to explore the area that's around you. So I always tell people that I plan my life around public transit. Where does it go? Is it gonna, I'm gonna choose a place to live where I'm on the public transit line. This tends to put me in downtown areas, which is fine. Those are also generally the places that have the best pedestrian environments as well. So I seek out places to be where my mobility won't be, inhibited by the fact that there aren't good pedestrian facilities or there is no public transit. However, if you're a person who's blind who lives in rural part of the country, then there's probably hopefully there's some transportation that might be available to you. But really, getting out and walking around and honing those O&M skills that you learn to use your cane or any other type of device is going to be more difficult because it's just not available to you. The level of risk. So one of the things that you're going to hear as a repeating theme in my presentation is that no matter how good you are with your skill set, travel for people who are blind always carries some level of stress. Sometimes it's pretty low, sometimes it's really high, but it's kind of always there. And so it's up to the individual to choose what level of risk you're willing to take. So consider the fact that for years, our pedestrian facilities have been built without consideration to how people who are blind travel and what people who are blind may need to be able to travel effectively. And so going out and using those facilities that do not have any elements that are going to help people who are blind automatically increases our level of risk over other pedestrians. So we've talked a lot about crossing intersections. And if you have an intersection that has a pedestrian signal that is a visual signal that lets people know when they can cross the street, but it's not audible or vibrotactile, then the risk for me crossing that street is greater. I'm having to guess when I have the pedestrian signal. And you're going to see a video of me crossing a street in just a minute that sort of brings that to light. Personality also plays a role. So if you tend to be kind of a bold person, you're going to step out and really try out those skills and do better, learn more things. Where if you're a little more cautious, you may be a little limited in where you will go. So all of these things are important. So when we're planning or designing pedestrian facilities for the public, it's important that we keep in mind that not everyone travels independently in the same way or with the same level of skill. And we want to make sure that our facilities work for as many people as possible. So there was a lot of information on the first webinar that happened on Tuesday about how people who are blind travel. And so I hope that if you did not participate in that webinar, that you listened to that recording. For the sake of time, I'm going to kind of jump through this particular slide a little quickly and only touch on a few things. But I use sound and touch. Those are my two major senses that I use when I'm out traveling around. We've already heard some of the things about audio cues and how the sound of traffic helps us stay oriented and know when to cross the street. The one that hasn't been mentioned that I want to mention is echolocation. And so echolocation, this is when you can hear obstacles because they interrupt the sound of open spaces. So when something, if wide open spaces, and then all of a sudden, you know, there's a pole or a person or a bus shelter or a wall that you're coming up on. That interrupts that open space sound, and you're able to actually hear it. This is not something that most people with vision pay much attention to, because you don't have to. I think I did threaten the last person who compared me to a bat, but it is that same type of system that bats or dolphins use in terms of using sound to that bounces off of buildings and other obstacles to stay oriented. And I use this quite a lot. You can go to YouTube and find some videos on echolocation. I kind of refer to that as extreme echolocation. I don't quite do it at that level. I was sort of self-taught with this, and so I just kind of use it in terms of helping to stay straight down a sidewalk by listening to the line of a building, for instance. Tactile cues, again, I can describe any place that I go on a regular basis by just what I feel under my feet. That's really important. Also, whatever I can reach with the tip of my cane. This is my touch or tactile information that I use to travel around. So the cane is an extension of my hand, and it reaches out there and touches a lot of things I don't want to touch with my hand, and wouldn't be easy to touch. And so it, you know, it kind of clears that space in front of my feet, so I know what's coming up. If there's cracked sidewalk, if there's a bench that I need to step to the left to go around, those kinds of things. You also get similar information through the harness for a guide dog. So the harness handle on guide dog harnesses is rigid. And the reason that it is rigid is so that you can tell the motion of the dog's body through that handle. So it's another tactile way to get little clues that the dog is giving you about stepping a little bit left or right to go around things, or stopping so that you put your foot out and see what it is they're trying to tell you is there, that kind of thing. So that's just a little bit about how people who are blind travel. We have a video that we're going to show now. So I'm going to stop sharing my screen to give it back to Dan. This is a video that the sound is going to be a little bit loud because you're going to hear the street noise, the traffic noise, and there's wind blowing on this particular day. But I do narrate the crossing. So Dan, if you want to go ahead and get that going. This is the top of a T intersection that I have to cross every day. And the sound cue I'm listening for is traffic moving in the parallel direction. So it's going this same way I'm trying to walk. Because it's a T intersection, I'm not going to get that sound cue. I can hear the traffic in front of me. And the only thing I'm going to be able to hear when this traffic stops is the turning traffic from the other side of the road. So that's my cue as to when I can walk. So we're going to listen to this for just a minute. We have good, strong traffic on Columbia Pike. No problem telling that I can't walk right now. Let's listen to this for a minute. Still moving through. You can still tell that. Right now it's getting a little quieter. That car is still obviously going, so I can't cross yet. Still moving. Alright, so I know it's getting close. Now I do hear a car turning. I can hear, I still have through traffic that way. Alright, I think I can cross now. All right, so that is, I'm sorry, let me get my All right. Are my slides back up?
Looks good.
Awesome, thank you. So, so what you will have noticed is that I did not cross that street very straight. This is actually a crossing that I make, or I used to make every day when I lived in the DC, Arlington, Virginia area. So I often hit it just perfect, just walk straight across those 4 lanes and hit it. But sometimes I don't. So I left it like this in the video because I wanted to show that this happens. No matter how good your skills are, these types of things are going to happen. There was absolutely nothing in that 4 lanes of traffic on Columbia that I was crossing that gave me any indication of if I was in the crosswalk or not. So I was guessing. I was pretty sure I lined up in the crosswalk, but there was nothing that gave me any cue that I was stepping out of it. Another thing to consider is that the sound of the wind, which you could hear blowing against the microphone there, also affects what I can hear and how I use it. So, so that makes it a little bit harder for me to cross streets when there's that kind of sound going on as well. This is going to be posted up with the webinar materials as well as 2 other videos we don't have time to show. And so feel free to download those and check them out later. So I want to move to some of the tactile wayfinding that we're implementing here in the Seattle area. Sound Transit has been using tactile wayfinding in our stations for a number of years at this point. And so what the picture on the screen here is of our waiting pad in one of our rail stations, and it's also showing the wayfinding strip that comes up to it and then leads away from it. So the waiting pad, we call those corduroy pavers. They kind of feel like corduroy and ridges under your feet and under your cane. So they're pretty distinctive. You can tell them easily away from the tactile warning strip, the truncated domes. It's also different from the tactile wayfinding paver itself. So you know that when you get to the waiting pad, that's where the train door is going to open. We have markers on our platform so that when the operator drives the train in, he stops at that marker, and then when the doors open, there is always an open door in front of the waiting pad. And we have 2 of these on each of our platforms for our light rail system. Now, the strip that's going up to the corduroy paver and then away from it, this is our tactile wayfinding strip. You can see that it, I hope you can see that it's sort of done in a braided strip design. So originally, the plan was to use typical bar tile wayfinding strip. However, when this went through the design process for Sound Transit and we had our art group looking at, things we can do to our stations to make them more attractive to folks, they said, wow, we can make this wayfinding strip a lot more attractive. And so they came up with this braided design, which I'm sure is prettier than the straight bar tiles, but it's not as functional. And so that was the piece that left out. You have to be a little aware. Sometimes aesthetics and function don't go well together. They can, but you have to work at both of them at the same time. You can't just say, wow, here's the function, now let's make it pretty and change it. And so that's kind of what happened here. We're going to be using bar tiles going forward for any stations that open from this point forward. One of the problems with the braided strip is that the crevices are pretty small and they collect trash and dirt and things like that. So it became much harder to detect it. The other thing I want you to know about tactile wayfinding, materials that you might use to try to make tactile wayfinding easier, is that just because it looks like it should feel different and just because it feels different when you touch it with your hand does not mean that you're going to be able to pick that up through the tip of the cane. So I'm working with a cane that's 5 feet out from me. The tip is on the ground. I'm running it back and forth. I'm walking. I'm listening to things. I'm thinking about where I'm going. And so the actual change in the tactile texture has to be significant enough to be able to detect it while you're walking, and through the tip of the cane. So just give that some consideration. And of course, the best way to figure that out is to have people who use canes help you determine what's the best surface to use. So this is a bike lane and pedestrian pathway that is separated with tactile markers. These are the bar tile markers. The city of Seattle has made a commitment to improving the pedestrian environment for people with vision disabilities, and this is one of the ways they've done it. So this helps both pedestrians and cyclists understand how to share this space together and safely. This is a transit island that is near my office in downtown Seattle. You can see that it uses handrails and fencing to direct pedestrians to walk up that island to the bus shelters and the bus stop in order to be able to catch their bus, and it gives them some protection from drivers. It's also very visible to drivers that this is where pedestrians will be. So as I've mentioned before, there's always some level of stress. Again, I've been doing this for 58 years, right? And no matter how familiar I am with a particular location, there are always things that change within that environment. And so there's always some level of stress. And so these are some things that I think we can start to incorporate in design that will help to alleviate some of that stress and make it easier. So first, consider the travel needs of everyone. Again, don't just focus in on that norm. You're going to be missing out on people who really need to use your facilities. So I will hope that you'll think about some of the things you've learned about how I travel. I do not fix on a visual point hundreds of feet in front of me and then start walking toward it. That's just not within my ability to do that. I don't do it that way. I do have a route in mind, and I know, generally speaking, what the layout is, unless, of course, I'm going to an unfamiliar place. And what I'm doing is working through a series of sequential cues that can be found through sound or the reach of my cane. So in a very kind of defined space around me, the extent of what I can hear and touch with my cane as I'm walking forward, this is what I'm using in order to be able to navigate. So let's just think for a minute about a blank slate sidewalk. So we've got a building edge on one side, we have the street on the other side, and we have this nice, lovely, smooth, flat, new sidewalk with nothing on it. So this is utopia for me in the pedestrian environment. This is something I could probably skate backwards down if I wanted to. But we don't ever leave sidewalks like that, and for good reason. So there are things that we'd have to start adding to it. So we, need some green space. We would put in some landscaping or some of those big planters that are usually, you found them at the entrances to buildings. If we want a bus stop here, you got to put up a bus stop sign, and you got to put up a shelter. There's utilities involved and other signage that has to be up. So there's a number of poles that have to be on the sidewalk. We put in trash cans so that people help keep our area clean. If there's restaurants in that building that we're passing, they often have al fresco dining. So you got chairs and tables out on the sidewalk. And then there are things that move around a bit, like A-board signs. So maybe they're posting a menu on their A-board, or maybe there's going to be upcoming construction and they've posted a temporary A-board sign to let people know this is coming. Or maybe there are caution cones that the city has left out so they can come back and work on some utilities. So these are all things that, now that you've added them to my nice, beautiful, flat sidewalk, that I have to navigate in and around. And then now let's add to that pedestrians and cyclists. We're talking about serious shared space here. So pedestrians often have strollers or luggage or backpacks that they're pulling, and you have cyclists moving around. All of these elements are in constant motion, and the best pathway for me to follow becomes even harder to discern. So now the design challenge becomes, what can we add to this shared space to help mitigate the stress of navigating it if you're a person who's blind? So tactile wayfinding is something that we've talked about that can help you direct down a path that you should be walking that would take you around those things that are otherwise obstacles. Accessible pedestrian signals certainly make crossing an intersection better. I still listen to traffic quite intensely, but I at least know when I have the pedestrian walk cycle. If I don't know, if I'm having to guess by sound of traffic when I have the the pedestrian walk cycle, then I'm gonna start walking a few seconds later than I should be walking. So then that gives me less time to cross the street. It means I have to hurry up a little bit. And really the bottom line is if we think that an intersection crossing needs a visual sign so that people who can see know when to cross, then I need that same information. And that's what an audible, vibro-tactile, accessible pedestrian signal do. There are also apps for smartphones that provide step-by-step instructions through GPS programs that can be very useful. There's some that just give you location information. So Microsoft has an app called Soundscape that you can download for free and play around with. And as you're walking down the sidewalk, you'll get information about what's around you. So it may say there's a Walgreens in front of you 30 feet to the right, or something like that. So those things are very useful. These are all examples of elements or features that can be included that makes it possible for people for people who are blind to navigate those shared spaces, and perhaps makes it even easy for us to travel as well. We spend a lot of time designing public spaces, public transportation, so that it's attractive to, easy for people to use it. We want to attract people to come in to use these facilities that we're building. And so we need to do the same thing for people with disabilities to make sure that it's easy and fun for us to use it as well. So I thank you for your attention with this. I'm happy to answer questions in the Q&A section later. This also has my contact email address on it, which is donna.smith@soundtransit.org. And I'd be happy to talk to any of you directly if you like. Thank you. I'm going to turn you back over to Beezy Benson.
All right, Beezy, if you want to take over the screen
here.
Yep.
Okay, there are 3 more presentations here that are all related to what are known as tactile walking surface indicators. First, I'm going to give a little bit of background. Then Rob Wall is going to talk about some research to solve a particular kind of a problem using tactile walking surface indicators. And then I'm going to talk about another research to find another solution. So tactile walking surface indicators were developed in Japan in the 60s as a guidance and warning system. They used raised domes or truncated domes to indicate cautions or a transition or point of interest, and raised bars that were oriented in the direction of travel to indicate the path of travel. They're used with some variations to some extent in most developed urban areas of the world, and are broadly standardized in an international standard ISO 23599, which allows a lot of latitude. Oh, why is my screen not advancing here? The standards that we have in the US were a result of a lot of research. Donna mentioned that it's very hard to detect a lot of surfaces that look like they would be detectable, like the wavy surface that's used on transit platforms in Seattle. No surface that was comprised of grooves in concrete was ever found to be detectable. It's important that it's detectable both underfoot and with a cane. Some things that are detectable with a cane won't be detected underfoot. Underfoot is sort of the most important thing because many people who are visually impaired don't travel with a long cane. But surfaces that were raised domes or truncated domes or raised bars that were 0.2 of an inch high were highly detectable, and it was found that about a 24-inch width in the direction of travel was necessary for most people to detect them and come to a stop without going beyond them. This is important in thinking about our detectable warning standard. The federal standard is a detectable warning of a minimum of 24 inches in the direction of travel, because they're usually used where you have either a drop off or traffic in front of you. So it's important that you not go beyond them without stopping. And it was also found when they were implemented that they increased safety at platform edges and curb ramps for all riders. I think one of the most useful standards, there's several, but it is the 2006 DOT ADA standards, and section 705 specifies the dome size and spacing and visual contrast. The drawing on this slide shows that the domes are 0.2 of an inch high. The base diameter can vary between 0.9 to 1.4 inches. And the top diameter is in relation to the base diameter, 50 to 65%, and the center spacing can vary from 1.6 to 2.4 inches. So there can be quite a wide variation. In point of fact, most manufacturers are manufacturing to the wider spacing of the truncated domes and the smaller domes. So the 2006 DOT standards require them both at transit platform edges and at curb ramps. When they're in curb ramps, they're the full width of the ramp, not including these flared sides. And they can extend either the full depth of the curb ramp, I don't think anybody's doing that anymore, or 24 inches deep minimum measured from the back of the curb on the ramp surface. As far as I know, the only other place that there is a different standard for that is that California requires 36 inches on curb ramps. The 2010 ADA standards, the most recent DOJ ADA standards, have the same specifications as in the 2006 DOT standards, but they only require them at transit platforms. It's the DOT standard that requires them also at curb ramps. Then we have the 2011 proposed PROAG, not yet a final standard, but considered the best design guidance for detectable warnings. Has the same standards for dome size, spacing, and visual contrast as the DOT and ADA standards, but it added much more specific language about the placement of detectable warnings on curb ramps and medians and islands. It talks about 3 different kinds of ramps: perpendicular, parallel, and blended transition. I'll let you go to that standard to see what they are, but there's quite specific guidance about different situations. Here's an example of a detectable warning surface in which you see that a person using a long cane has just stepped onto a yellow detectable warning at the bottom of a curb ramp at what appears to be a mid-block crossing. Here are a couple of other example installations. The photo on the left shows a 24-inch deep area of detectable warning surface for the full width of a blended corner at a crossing. And on the right, a yellow detectable warning is used as a splitter island that's cut through. They mark the beginning and end of the protected pedestrian path through the island. Guidance surfaces are not standardized in the US. A typical surface is raised parallel bars that are less than 1/4 of an inch high, about the same height as the truncated domes. The surface that's shown in the photo is, however, standardized in California, and it's been used for some time there to indicate where railed vehicles doors open along transit platforms. The flat top bars are 0.9 inches wide at the top surface and 3 inches apart on center, and the bars are typically oriented in the direction of travel along the surface. Guidance surfaces have been installed at a number of transit platform properties, including and around some bus and rail stations. Most of them used a raised bar surface, but there are a lot of variations. Here are a couple of examples. In the drawing on the left, a black 12-inch wide raised bar guidance surface leads through a fare gate in a transit station. And on the right, a yellow 6-inch wide guidance surface leads on 2 sides of a wide sidewalk from a transit station out to a bus stop. And 2 more examples here on the left. A 24-inch wide black guidance surface leads to the stairs in a transit station. And on the right, a 6-inch wide yellow guidance surface leads along a sidewalk to a bus stop. Detectable warnings are now installed or planning to be installed on all transit platforms in the US at the edge of the platform. This is different than they are in lots of other places around the world where they're set back from the edge. And you see in this photo, the yellow guidance surface right at the edge of the platform at the drop, and then a 6-inch wide black surface along the edge of the detectable warning that is farther away from the drop to increase the contrast between the brick red of the platform and the yellow of the detectable warning. And then there's a 5-foot wide, 3-foot deep rectangle of raised bars that indicate where the train door will open. This slide shows a 6-inch wide guidance surface that had been used in Seattle to delineate between the pedestrian and cycle sides in a sidewalk level separated bikeway. They found that 6 inches wide wasn't enough, and they're in the process of changing that to 12 inches wide. In this photo, a 24-inch deep area of a detectable warning surface indicates where pedestrians are intended to cross the bikeway. There was a project concluding in 2017, an FHWA project that Elizabeth Hilton was leading on accessible shared streets. And it gives the title of the report is Accessible Shared Streets, Notable Practices and Considerations for Accommodating Pedestrians with Vision Disabilities. And a quote from that is, surfaces that are reliably detectable and identifiable should be used to define a linear, obstacle-free pedestrian access route through the comfort zone. There's been some recently completed research that extends this thumb. At the conclusion, I will be talking about research to identify a delineator for separated bike lanes at sidewalk level that's highly detectable to pedestrians with vision disabilities and crossable by people with mobility disabilities. This was an activity of the Better Market Street project in San Francisco, and came out with a recommendation that a raised trapezoidal strip, 0.75 inches high, 6.25 inches wide at the top with sloping sides at a 22-degree angle should be used as the delineator for separated bike lanes at sidewalk level. So ongoing research on TWSIs, Rob is going to talk about this in a minute, the project was called Effective Guidance Surfaces on Travelers with Vision and Mobility Impairments. And this was research on a novel use of a guidance surface to aid in locating crosswalks and aligning to cross in challenging locations. And additional ongoing research that Janet Barlow and I are both involved in is tactile wayfinding and transportation settings for travelers who are blind or visually impaired. So this includes both public rights of way and transit. It's under the Transit Cooperative Research Program B46 and led by the Highway Safety Research Center at University of North Carolina. It consists of some laboratory research that, first of all, will identify the geometry of a guidance surface that's highly detectable and discriminable from the detectable warning surface. You've got to be able to find it, and you've got to be able to know that it's not the truncated domes. And it will determine whether a special indicator surface is needed at choice points and identify a recommended surface if this is needed. This is common internationally. We're not sure whether it's really needed, so we'll do some research on that. There will also be some field research in transit and public rights of ways in at least 2 cities. And finally, preparation of a comprehensive guidance manual for use of tactile walking surface indicators in transit and public rights of way, including detectable warnings, guidance surfaces, and delineators for use between pedestrians and bikes on separated bike lanes at sidewalk level. And now I'm going to turn it over to Rob, who will talk about the research to help blind people locate hard to find crosswalks and a line to cross.
Thank you. And I will try and share. Hold on.
We've got your screen now, Rob, if you just want to, yep, there you go. You're all set.
Okay, there we go. Thank you. All right, some of the slides that I'm going to be talking about to some extent have been referred to already in people's comments, and so in the interests of time, I'm going to perhaps truncate my comments a little bit on some of the slides. But of course, these slides are available through the PDF, and so you can view them later at your leisure. So as BZ said, I'll talk about the specific project looking at the use of guidance services for people with visual impairments, as well as mobility impairments. As people have talked about already, in the United States, tactile walking surfaces are used primarily as what we call detectable warnings. These are the truncated domes at the bottom of wheelchair ramps, and this is prevalent because when wheelchair ramps first became more ubiquitous within the built environment, people who are blind could easily walk into the street without realizing it. And so the answer is that detectable warnings, the truncated domes, are placed at the bottom of ramps simply to indicate the place where the walking surface transitions to the road surface, but there is no actual step down or step up. There's no level change. That, to some extent, solved the problem of people who are blind walking into the street down the ramp, but it has led to some other secondary issues. The bottom of a wheelchair ramp isn't always the place where a person who's blind should stand to cross the street. It often is, but it isn't always. And so it leads to the misunderstanding that that is where you're supposed to stand. There's 5-10% of the time that is incorrect. The other, I think, common misconception is that people who are visually impaired or blind get alignment for their crossing from the detectable warnings, and that is incorrect. They are detectable underfoot and by the cane, but they do not provide any kind of alignment information. And so I have here a picture of 3 different installations of detectable warnings. The picture on the left shows that at a corner with 2 crosswalks coming out of it, even though there's a blended corner so that there's no level change around the entire radius of the corner, 2 sections of detectable warning have been placed simply at the beginning of the 2 crosswalks. Some kind of signaling that they're to be used as at least a landing pad for the crosswalks, but suggesting that maybe alignment for the crosswalk, and that would not be true. The other 2 photos show also blended corners, but with the detectable warnings going all the way around the corner. And so that certainly would prevent or would signal to a person who is visually impaired all the places where there is a transition from the walking surface to the road surface with no level change. However, it provides absolutely no indication of where a person should stand for either of the crossings from that corner. And given that it's this blended corner, there's a lack of any reference for alignment. Now, Donna did talk about using traffic. Traffic flow is a very robust cue for people lining up to cross a street. However, if you're faced with certain kinds of crossing situations, such as a skewed crossing, that robust alignment to traffic can lead you to align incorrectly for the crossing. And on a corner like these, you wouldn't know that until you started crossing and did not end up going where you thought you were going to go. BZ mentioned that there are these guidance services that are used in many places, many other countries, and then more recently in the US for different functions. These parallel bar tiles, guidance surfaces, can be used for alignment. If a person who's blind or visually impaired stands on these bars so that they run perpendicularly under the balls of the feet, often you stand on the very first line of bars or the very last line of bars in the set of parallel bars, you can get a sense of alignment from that. And as long as these are installed to actually be lined up with the crossing, that does provide a tactual alignment cue for the crossing. And so for this project, we looked at those bar tiles, which I'll refer to as guidance surfaces, to indicate where a pedestrian would stand to cross and to provide alignment information. And we used these at crossing places that might be confusing. Roundabout crosswalks, mid-block crossings, skewed crosswalks, places where either the traffic or, well, the traffic would lead to incorrect alignment, or it was difficult to decide where exactly a person was supposed to stand to cross. And I want to highlight that we didn't think that this would be used to replace detectable warnings. These would be used in conjunction with detectable warnings. Detectable warnings serve one function, which is to indicate the bottom of the wheelchair ramp, the boundary between the walking surface and the road surface. And then these would be used only at certain difficult crossings to indicate more precisely where a person should stand and to give them some alignment information. We did two phases. I'm going to talk about phase 2 first. That was with people who were visually impaired and blind. The first phase was people with mobility impairments, and I'll talk about that after this slide. But we looked at a lot of different kinds of problematic crossings, skewed crossings, crossing the top of a T, very large radius corners, apex ramps. That's a good example of a place where the patch of detectable warnings may not necessarily indicate where you should stand for either of the crossings. The first part of our data collection in Sarasota and Alexandria, we looked at installations of these guidance surfaces that extended from the bottom of the ramp all the way across the sidewalk to the building line. And there's a picture of a mid-block crossing where we did that in Sarasota. And that is so that a person who's walking down the sidewalk next to the building would encounter these detectable warnings, or sorry, these guidance surfaces, and that would indicate that there was a crossing place off to their left. If the guidance surfaces didn't extend all the way across the sidewalk, it might be very difficult for the person to realize that there was a crossing place. The picture on the right shows how we approached the placement of these guidance surfaces in Seattle, and then when we went back to Alexandria, where we just used smaller 2x2 foot sections of the guidance surfaces and typically installed them next to the detectable warnings, if there were detectable warnings. And you can see how in this placement of an apex ramp, the guidance surfaces are right next to the detectable warnings, but they are over enough that a person standing on the guidance surfaces would be in the middle of the crosswalk. They would be aligned down the crosswalk, and they would not be standing on the detectable warnings or on the ramp at all. We tested the placement of these guidance surfaces with people with mobility impairments who used manual and power wheelchairs, mobility canes, crutches, walkers, a variety of mobility aids, to see how them traversing these surfaces in different ways might create problems. And it turns out that for almost all of the participants in that study, crossing the guidance surfaces parallel with the line of the raised bars was the easiest way for them to traverse them, the least inconvenient way, which works out well because that means that in that installation at the mid-block crossing with the guidance surfaces extending across the entire sidewalk, a person, say in a wheelchair, just going along the sidewalk would roll right through the grooves between the raised bars, ideally, and not experience any discomfort. And if they wanted to turn and go down the ramp to use the crossing, these would not be on the ramp either, and so they would not be inconvenienced in that regard either. And so this way of installing these guidance services seems to serve both the population with mobility impairments and visual impairments best. The findings for the people with visual impairments is that they did find these services well. A little bit less in the first round in Sarasota, but in the other sites, it was in the 90 percentile. Their alignment, we collected data both with and without the guidance services at all these crossing places. They aligned much faster when the surfaces were in place. They also aligned much better, and this was a dramatic change. In every single site that we went, the precision of their alignment for the crossing was at least twice as good, sometimes 3, 4, 5 times as good as without the surface. In all the site locations, they aligned or tended to align on the ramp, on the detachable warnings, or on the guidance surface. So if the guidance surface was there, then they were standing in an appropriate place much more often than if the guidance surface was not there. They almost always aligned within the crosswalk. They tended to align fairly well, at least within the crosswalk without the surface, but it always improved with the surface installed. So generally, people who were blind in our study were able to find those surfaces and align to them to cross much better than with the surfaces if the surfaces were not there. But finding them was not always a sure thing. If a person has particularly poor orientation or doesn't know about these services or what they mean, that might cause some confusion and some inconsistency in their use. And so installing them in a consistent manner and some sort of educational program would probably be important if they were used more. In non-corner crossings, like that mid-block crossing or the top of a T, they might need to extend across the entire sidewalk to the building line. Corner placements probably would be best to use the smaller 2 by 2 foot segments. Otherwise, longer segments of the guidance surfaces will interact with each other and create some confusion. With the very skewed crossings, when the streets are not at right angles to each other, sometimes it got a little problematic in figuring out exactly where the best place to put the surfaces was. So there may be still some work to be done to figure out what the best installation parameters are for every situation. We do already have out a synthesis of tactile walking surface indicators in the US and international, and we're in process of developing a guidance document from this on how to best use these guidance surfaces to help people who are visually impaired locate crosswalks and align to cross. And with that, I will yield my time back to Beezy.
So now we're going to hear about some research that I conducted to identify a delineator for separated bike lanes at sidewalk level. A lot of jurisdictions are wanting to install these, but recognizing that there needs to be some kind of a delineator for people with visual impairment so that they know when they're on the pedestrian side. I think I skipped a slide there, yes. So the research was conducted as a part of a redevelopment project in San Francisco, the Better Market Street project that is redeveloping a 2.2-mile stretch of a major artery to limit access to vehicles other than transit and increase the sidewalk width to benefit pedestrians, and also to provide a sidewalk level bikeway to increase the safety as cyclists. And they knew that they needed to provide a detectable tactile delineator between the pedestrians and cyclists, and were willing to spend the money to actually do some research on it. So in the approach to identifying a delineator, there isn't any US standard or guidance for that. But we needed to conduct human factors research to identify a delineator that was at least as reliably detected by pedestrians who are vision disabled as the truncated dome detectable warnings, and accurately identified by them, and that also was not a barrier to crossing by people having mobility disabilities. Now, the idea is never that it would be placed in an area which is a crossing, is a planned place that any pedestrian, including pedestrians with disabilities, would in fact be crossing. But it shouldn't be a barrier so that if you should need to cross it, a person with a mobility disability couldn't get across it. I'm truncating some of this presentation. There will be more slides if you are interested in looking at the posted version of this. But there were 4 surfaces tested. First of all, we were testing truncated domes as a baseline because we wanted to make sure the others were identifiable from them, discriminable from them, and at least as detectable. So we used the truncated dome surface that is most common in San Francisco, which has the closer spacing in it. And we compared that with a directional surface, the most common directional surface of raised bars that we're seeing in the US, the one that is standard in California, that has 4 bars on a 12-inch tile, 0.9 inches wide. And then a pattern that we call corduroy, which had narrower bars that were a little closer spaced. And then one that was quite different, that was based on the guidance that existed in the UK for a couple of decades for a surface to use exactly for this purpose, separating bikes and pedestrians at the same level, which was a raised trapezoid. Now point out that the trapezoid was raised 0.75 inches. That's a lot higher than the others, which were all 0.2. And these were all done on 12-inch tiles produced by a company called Strongo. They were laid out 40 feet of each surface was laid out embedded in concrete that was level with the base of each surface in a pier in San Francisco. The research participants, there were 2 groups, 26 vision disabled who used a long cane, and 30 with mobility disabilities who used manual or power wheelchairs, canes, crutches, various walkers, and no aids, but had difficulty walking. So what did they do? The vision disabled participants had 3 tasks. One was to detect the surfaces, one was to identify them, and one was to follow them. For detection, they approached each surface 6 times, twice from 90 degrees, and 2 approaches each from approximately 25-degree angles to the left and right. The 90-degree approach would, like, if you can imagine, coming out of a building and approaching the delineator and wanting to know how much width of sidewalk you have here so that you're not going beyond it. The narrow angle approaches, which it's the first time this research had been done in this way, are thinking about the pedestrian who is walking down the street, assuming that they're walking parallel and more or less in the center of the pedestrian way, but is gradually veering and getting closer and closer to the delineator and needs suddenly to recognize it when they're not anticipating that it's going to be there at all. The task that we had them do for identifying it was they were guided onto each surface 8 times at various angles, stepped off after 3 seconds, and identified the surface as domes or bars, any kind of bars, or the trapezoid. And for following, they followed each surface for 40 feet with the surface on either the left or the right. I have in this presentation, if you want to look it up later, a number of short videos. I'll just show one here of detection. This is a vision disabled participant approaching a 12-inch wide corduroy surface from 90 degrees, and he detects the surface with a cane, stops without stepping on it, but the cane goes more than 6 inches into the bikeway. As I say, there are a number of short videos that you can see of the detection task. So what did we learn? Basically, we learned that they were all highly detectable. It didn't matter whether you're approaching them from 90 degrees or a narrow angle. I should point out that this measure of detection, sometimes they would detect it and stop going beyond it, or the cane would go beyond it. But it was detected by either the cane or the foot. They were all highly detectable, regardless of the direction of approach. So anyone could be chosen based on that. When it came to identification, and there's also a slide that shows how that was done, if you look it up on the posted version. There was a marked difference, significant difference in identification of surfaces. The trapezoid was identified on almost 100% of trials, regardless of whether it was approached perpendicularly or at some angle. Different than all the others. The corduroy and the flat top bars were both often confused with the detectable warning surface. That the trapezoid was just unmistakably identified as trapezoid. There's also an example of following the surface. If you look at the posted version, participants successfully followed the surfaces without losing them on 302 of 312 total trials. So any of them, you can follow them. No significant difference in following them. There were, however, significantly higher rates of cane intrusion for the 12-inch surfaces than for the 24-inch surfaces. So what about the mobility disabled participants? There were 3 tasks for them. They had to cross each surface 4 times. But they were told that if you don't have to cross any surface that you think wouldn't be safe for you to cross, or if you make one crossing and it's particularly difficult or uncomfortable for you, you can say you'd rather not cross it again. So it really emphasized that they shouldn't cross a surface that seemed like it wasn't going to be good for them. And then as they did that, they were rating each surface for effort and stability and comfort in relation to crossing the detectable warning, which they also crossed, just to remember what that felt like. And then finally, at the end of the procedure, stating a preference for the use of the wide bars or the corduroy or the trapezoid as a delineator. So just one short video here of a person in a manual chair crossing the trapezoid. Up and over quite easily here. So the results were that all the surfaces were readily crossed 4 times. No surface was a barrier to crossing, regardless of what the aid was. They were all readily crossed 4 times. Nobody hesitated to cross them additional times. In the ratings, there was little significant difference from the detectable warning surface in effort or instability or discomfort. The trapezoid was the least preferred as a delineator, but some participants said they cared more about having a delineator that discouraged crossing by bikes, the one that was easy for them to cross. So the final recommendation was to use a trapezoidal indicator between the bicycle and pedestrian sides of a separated bikeway at sidewalk level. The drawing shows the trapezoid as created on a 12-inch tile. The trapezoid itself, the top of it is only 6.25 inches wide. It is 0.75 inches high. And finally, there's a rendering of how this would look on the street, Market Street in San Francisco, in which the rendering shows from right to left, a transit lane, about 4 foot wide raised strip between that and then an 8 or 10 foot wide bicycle lane, then the trapezoidal delineator, then a furnishing zone, and then the pedestrian way, and then the building line. I hope that's been helpful to you. I know that we are running out of time and that we do want to have time for some questions. So I will end here.
Hey, thank you so much, Beezy. I think I'd like to go ahead and transition us over to that Q&A period. So hopefully you can see the screen. You have access to it in the PDF copy of the presentation because it has the contact information for our panelists. If you want to reach out to them, we'd encourage you to do that. I think they included their contact info in all of their presentations as well. It's all on one page in the PDF copy of the presentation, so it's there for you. Let's go through some questions. A few of them came up numerous times, so I want to get to them. One point of clarification on one of those last points that BZ you hit on. Is there a proper or appropriate orientation for the bars on those surface treatments along the roadway? Some showed them parallel to the street, others were perpendicular. Could you summarize that for us, and maybe the ones that you see are the best ones to use?
Yes, I will. And I think it depends on the use for them. Normally, for use for guidance, where you are trying to define a path of travel, the bars should be oriented in the direction of travel.
Okay, wonderful.
For the use to identify, to help a blind pedestrian locate a crosswalk or a line to cross, they're oriented perpendicular to the direction of travel on the crosswalk. And that is different than international practice. And that's why we needed to do the research with people with mobility impairments to make sure that we really were not going to be doing a bad thing to recommend this. But we wanted a single surface that people could both, that blind people could both use to identify the location of a crosswalk and align with. And we know that it's not psychophysically possible to achieve great accuracy, aligning to something that goes in the axis of the foot. That is, if we align them in the direction of travel across the crosswalk. So we align them perpendicular to the direction of travel across the crosswalk. Okay. So normally, if it's a guidance surface intended to guide somebody someplace, yes, it's going to go in the direction of travel. It's just this very special situation, which will not be used at all crossings, but only ones that are hard to find or have missing or confusing cues about alignment. We would have this surface in which they're aligned perpendicular to the direction of travel on the crosswalk.
Okay, wonderful. Thank you for clarifying that. Another question, I'm not sure who is best to take this one, so I'll extend it to everyone. Lots of questions about in conditions and locations where snow, ice, and other winter weather are prevalent. What are some considerations for maintaining these tactile surfaces and clearing them of this ice and snow so they can be properly used?
Different jurisdictions do that in different ways. I think where it's a particular issue, one of the most effective ways to do that is with a very stiff broom. I've seen that used in Fairbanks, Alaska, for instance. But it's done in different ways, not always done very well. They don't always remain very detectable, but they, even though they're not so detectable as the truncated domes, they usually provide a certain amount of grittiness on the curb ramp, and so may have an effectiveness that way.
Okay, wonderful. This is another area where I'm sure you all get these questions a lot, but the topic of quiet vehicles. Donna, when you showed the video earlier on, the traffic noise was a big cue for you, but we obviously electric, hybrid, other quieter vehicles aren't giving off the same noise always, and so there are some questions about how can we best handle this issue? Is this something that's being done from a manufacturer's standpoint, vehicle manufacturers, or are there other ways to make sure that these aren't threats to the safety of those with low vision?
So that's a very good question. You know, from a personal standpoint, I probably pass quiet cars a lot and don't know it because they are quiet. However, if they're moving in the traffic flow, they're not generally quiet at that point. So if I'm trying to determine is traffic moving or stopped, then I can usually tell they're quiet when they stop. And as they start to accelerate, you don't get that good, you know, noise about a car accelerating. But nevertheless, it can be a problem. It's more of a problem if drivers don't follow the rules and do things like pull up into the crosswalk, those types of things, turn in front of pedestrians. One of the videos that will be uploaded for you to see is me crossing K Street in DC, and this was not a quiet car. I heard it, but there was a car that turned in front of me and cut me off, even though I had the cycle to cross. So there was some discussion with manufacturers about things that you could do in order to make it so that there was some level of sound as soon as that car starts up. But I don't think anything has been passed thoroughly. I'll defer to my colleagues here if they have more information about it.
Yeah, this is Rob. I just want to make a couple of comments on the quiet car issue. One is that for moving vehicles, once a vehicle is moving more than 25, 30 miles an hour, the sound you hear is from the tires on the road. And so no car is technically quiet at that point. Quiet cars per se, hybrid electric vehicles, are more of a danger at slow speeds, turning maneuvers, you know, coming up from a stop at a red light, that sort of thing. And so you can still get alignment from traffic if there's a good traffic flow. The issue with quiet cars is that they raise the risk at, say, street crossings, because if they're starting from a stop, then it's harder to detect them. We've worked with Nissan and GM and some other manufacturers in the past to look at which sounds could be used to add to these vehicles to make them more detectable. Unfortunately, sounds that make vehicles more detectable are not the same sounds that make them more localizable. And a person who is visually impaired or blind wants to do both. And so there's not a good solution to this yet, but at least NHTSA has put forth suggestions on what kinds of sounds, or at least parameters of sounds, that auto manufacturers should add to their quieter vehicles to make them more detectable. And there's a host of publications about this.
Okay, wonderful. Thanks so much for both of those responses. The other question that came up a couple of times is with respect to PROAG. We mentioned public rights-of-way accessibility guidelines a few times, and the question is whether there are any examples of state agencies or local agencies that have adopted PROAG to guide their own activities in the absence of it being a sort of a nationally mandated document or guidance at the moment. Does anyone have a response to that question? And then the second part of that would be, can agencies adopt it as their own guiding policy? I'm not sure who the best person to take that would be.
So I'll start. Absolutely. If an agency or a municipality or local jurisdiction wants to adopt the PROAG guidance in as the guidance that they're going to follow when creating, pedestrian environments, you certainly can. It's there, obviously, to be used as guidance, and it is currently the best guidance that's available. I don't know of any who have formally adopted. I know a lot who use it. And at Sound Transit here in the Seattle region, we certainly defer to PROAC when we're looking at, often when we put in our stations, we're also doing work changing the public sidewalks, or a pathway to a park, or a walking trail, those types of things. And so the PROAC is what we always go to try to make sure that it's as accessible as we can make it.
Okay, Wonderful. No, thank you so much for that. Since we got started a few minutes late, I'd like to squeeze in one more question before we end. I understand if you all have to drop off, but I did want to ask this question. It gets back to the topic of maintenance. We talked about cold weather and maintaining streets and sidewalks in ice and snow, but the topic of maintenance has come up so many times in the chat pod, both in this session and on Tuesday. On Tuesday, folks were asking about the best ways to make sure that APS that are out there, they're actually working and they're actually available for people to use. So there were indications that sometimes people are trying to use them and they're just not in operation at the moment for whatever reason. Same can be said, I think, a lot of questions about these tactile walking surfaces, the truncated domes, these mats that are pulled off, ripped off the street, they fall out. And so I have a question that's sort of in two parts. Is there a really good place to look for processes, documents, guidelines for maintaining streets for accessibility? And then do you all have recommendations on the best ways cities can be set up to allow users to report things like this to them very quickly so that they can be repaired? I suspect that if an APS is broken or not in operation, the city may not know that right away, and it may be worthwhile for to have a way that people can quickly tell them and report that. And so I wanted to offer those questions to the panel as maybe our last question of the day. And I don't want to put Donna on the spot again, but that second part about an agency response to communicating with end users, I wonder if your agency is in that position, or if Seattle DOT, I'm sure you work with them a lot, do they have a good method set up for people to report things that are broken or that need to be repaired?
So they do. So the Seattle DOT has an accessibility and ADA coordinator. And so they have a general email box, which I don't remember the address to, but you can send in information about things that are broken or things that, if you want an APS in a particular location where there's not one currently. And Sound Transit has the same option. Again, we're doing some pretty aggressive expansion projects and expanding light rail out around the region. So we're doing a lot of construction, which inevitably interferes with, the location that we're doing the construction in. So, we have an email address and a phone number that people can contact us directly if they have accessibility questions or concerns or comments. So this is probably pretty prevalent around the country, and if it's not, I urge you to get in touch with the city and the Public Works Department and start asking, who do I contact? How can I make this information available?
Great. Thank you. I do think that that communication, we talked about that a little bit on Tuesday with respect to making sure that planning processes allow for all people in the community to to have their voice heard. And I think that responsiveness needs to match that as well, giving people a way to get that information over to the city when they need it, or the state agency. That is going to be unfortunately, the last question of the day. I do hope you all are able to reach out to us or our panel to ask other questions if you're interested in other resources and things that we can provide you with. I've just really enjoyed learning more about this topic this week on Tuesday and on Thursday. So I just wanted to extend a huge thank you to our panel and providing their perspectives and their expertise. And I'm really appreciative that you all were able to join us for these webinars. You'll have an opportunity to share some thoughts with us in a survey after the webinar. I'm going to be sending you an email with a lot of follow-up resources, the link to the certificate page again, the archive. We'll have that recording up this afternoon. You'll be able to look back at that and share it with others who may not have been able to join us. And I hope you'll be in attendance for our future webinars. We've got a lot of sessions coming up that I hope you can join. So once again, thank you all so much, and we'll see you next time.
Thanks, everybody. I'm going to go ahead and end the webinar. Have a great afternoon.